Morning, everyone. Welcome to Introduction to Logic, Deductive and Inductive Reasoning. So finally, tapos na ang midterm. We are already at our finals week. And to start off our finals week, we have week 13. So week 13, our topic is about logical connective. So for this week, ang discuss natin is the logical connective. So for logical connectives, we have the propositional variable and the types of it. So let's proceed to our discussion. So propositional variable is a variable which used to represent a statement. So a formal proposition is written using propositional logic. So ano tong mga propositional logic? We have P, Q, and R. So P, Q, and R, these are used to, P, Q, R. So these are used to represent our statements. So logical connectives are used to combine simple statements which are referred to as compound statements. So compound statements is a statement composed of two or more simple statements. So that are connected by logical connectives and, or, if, then, not, if, and only if. So sorry, medyo mahaba siya. And exclusive or. So ito yung mga logical connective. So again, we have and, or, if, then, not, if, only if, and exclusive or. So a statement which is not compound is said to be simple, and it is also called atomic. So kailangan para maging logical connective siya, it should have two simple statements. And logical connective, nagiging compound statement na siya. So in order for us, again, ano ulit yun para maging compound statement? Kailangan meron siyang logical connectives na mga and, or, if, then, not, if, only, if, exclusive for. So before proceeding to our discussion na yung mga variables natin or connectives natin like the conjunction, we also have disjunction and also negation. So and conditional. So ito yung mga logical connectives natin. I will show you a video discussion para mas malinaw itong lesson natin regarding about logical connectives. So we have here the truth tables for negation, conjunction, and disjunction. So I will post this on our Google Classroom for the link for this one. But for the meantime, lagay muna natin siya dito sa ating presentation.
We're going to start creating truth tables in this section, and I'll give you some pointers on how to do that. A truth table is used to determine when a compound statement is true or false. So if someone tells you a phrase, you need to break it down into multiple parts and use the truth value from each statement to determine if the entire statement is true. The first thing you're going to deal with is the negation. So remember, the negation is read as not P. When dealing with the negation, if the P statement is true, then the negation of that statement will be false. If the P statement is false, then the negation of that statement is true. So in other words, the negation of P will always have the opposite truth value of regular P. So for example, if I said Disney World is in Florida, that's my statement P. That statement is true. So the negation of P, Disney World is not in Florida, would be false. This table is just a summary of what we just stated. So your statement has two cases. Your statement can either be a true statement or a false statement. If your statement is true, the negation of that statement will be false. If the statement you make is false, the negation of your statement will be true. If you have a compound statement, that means you have two phrases that are connected together. There's 4 cases that you can get. Both of your statements could be true. Your first statement could be true and your second false. Your first statement could be false and your second true. Or both of the statements you make could be false. This is going to come into play when we do truth tables for conjunction and disjunction. Remember that conjunction, P and Q, is only true when both P and Q are true. So the conjunction truth table is going to look like this. Case 1, if both of your statements you make are true, then the conjunction of that statement will be true. But in any other scenario, if the second statement's false, if your first statement is false, or if both statements are false, the conjunction of the 2 statements will be false. Disjunction, which is read P or Q, is going to be true whenever P is true, or whenever Q is true, or whenever both P and Q are true. So basically, the only time the conjunction is false is when both P and Q are false. So the truth values for a disjunction will look like this. If your first and second statements are true, the disjunction will be true. If the first is true and the second is false, your disjunction will be true. If the first statement is false and your second statement is true, your disjunction will be true. And the only time the disjunction is going to be false is if both the statements in your compound statement are false. So let's look at creating a generic truth table and see if you're getting the idea of this. Okay, so in this one, we are going to do the negation of the group, the negation of Q, disjunction P. So not Q or P negated. Okay, so what I like to do, and I sometimes do mine a little different, I use what's called the alternative method, but I like to map everything out. So the first thing I do when I go to make my T-table is I list what my statements are. You do want to list them in alphabetical order. Okay, so I have statement P, and I have statement Q. And you just want to list these generic. So when you have 2 statements, there are 4 ways that you can answer. They can be both true. You could have a true false. You could have a false true. Or you could have a false false. Okay? Then I look and I work my way from the inside out. So first I'm going to start with the parentheses. And I need to figure out what the negation of Q is first. So I'm going to make a negation of Q column. So all I have to do to figure out what the negation of Q is look at the Q column and make everything the opposite. So the Q column is true, false, true, false. So the opposite of that is false, true, false, true. Then I need to find the negation of Q or P. So I make a new column for the negation of Q or P. So when I do that, I'm going to look at the negation of Q first, and I'm going to look at the P column second, and I'm going to follow the truth values of disjunction. So disjunction is always true unless both the first and second statements are false. So remember, you have to go in order. So my first statement is false, my second statement is true. I did get a true value in one of the statements, so the disjunction would be true. First statement's true, second statement's true. That creates a true value. First statement is false, second statement is false. That is the only time the negation is false. Or excuse me, the disjunction is false. First statement's true, second statement's false. That makes a true statement. Then I need to go one step further. I need to take what I just found and negate it. So I need to do the opposite of what I just found. So the final answer will be false, false, true, false. And you've just created a truth table. Now it seems a little weird, like what exactly do you have here? Well, what you would do is you would use this to analyze someone's argument. So, if somebody had a true statement and a true statement, so Florida is in the United States, Disney World is in Florida. Those are your two statements. And then they went through and you could analyze it. And if they phrased something about Disney World and Florida in this way, you could determine that it is a false statement. Okay, let's look at another one. This actually asks us to use the alternative method. That's what I just showed you. I typically always use the alternative method because it's just how I am used to creating truth tables. So this time we want the negation of P and the negation of Q, and we want to develop a truth table. So again, we have two statements. We have statement P and we have statement Q. If you have a statement, if you have a compound statement that has two items in it, there's 4 different ways you can answer the question. So one way you can figure that out, you can take 2 raised to the number of statements that you have. Since we have 2 statements, we'll take 2 to the 4th power. There's going to be 4 different combinations for ways we can answer. So under the P column, we'll put true, true, false, false. And under the Q column, true, false, true, false. Now, we need to figure out what the negation of P is. We also need to figure out what the negation of Q is. And then once we know what those are, then we can do the conjunction, the negation of P and the negation of Q. So let's just first start with the negations. So to negate P, I just need to look at the P column, which is true, true, false, false, and I'll do the opposite of that. False, false, true, true. To do the negation of Q, I look at the Q column, which was true, false, and I will do the opposite. False, true, false, true. And then to do the conjunction, I need to look at the not P and not Q. So we get a false and false. That's false. False and true. That's false. Because remember, conjunction is only true if both statements are true. We have a true and false. That's false. And we have a true and true. That is the only time conjunction is true. So the only time not Q and not P would make a true statement was if both the original phrase had P and Q both starting out false. I wanted to show you one more example. And this one's going to have 3 phrases in it. Our first phrase is Santa is home. So we're going to let Santa is home be statement P. Our second phrase is he is not at his desk. He is not at his desk is going to be statement Q. And our third phrase is he is sleeping. We're going to let he is sleeping be R. Now see how we have 3 phrases in this problem? So if we take 2 and raise it to the 3rd power, there's going to be 8 possible ways to combine the trues and falses of 3 phrases. So I always do the P column first. If I need to come up with 8 different combinations, I'm going to need 4 trues and 4 falses. And then in my Q column, I'll do 2 trues, 2 falses, 2 trues, 2 falses. And then in the R column, I'll alternate true, false, true, false, true, false, true, false. Okay, now I need to put my connectives in the problem. Santa is home and he is not at his desk. Okay, so the first thing I need to do is figure out not at his desk. So remember, at the desk was Q. So I need to do not Q. And then once I have not Q, I need to do the connective Santa is home and not Q. So Santa is home is represented by P. So we need to do P and not Q. And then once I have that answer, we need to connect that with the connective or. Now notice there's a comma after at his desk. So they're telling you that P and not Q is in a set of parentheses on the left side of the connective or. And that he is sleeping is on the right side of the connective. Okay, so whatever we get in that last column is going to be our truth values. Okay, so not Q is not going to be terrible. I just need to look at the Q column and do the opposite. So the opposite of the Q column is false, false, true, true, false, false, true, true. Then I need to do the conjunction, P and not Q. So I have a true, false, that what makes false. Because remember, the and is only true if they're both true. True, false, true, 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 false, 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 true, false, true. Okay, now that I have the left side of the expression, I need to take the left side of the expression and the R column. So I need to take the P and not Q, and I need to take the R, and I need to do the disjunction, the or. Now remember, the or is only false if they're both false. Okay, so remember, you need to do the P and not Q first. So we have a false, true, false, false. That's going to make a false. True, 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 false, false, true, false, false. That is false. False, true, and false, false. That's false. So this last column in purple is going to be considered your solution to your truth table. Now, sometimes I'll ask you to determine the truth value of a statement without going through and creating this the whole truth table, because that can sometimes be a little bit time consuming. So don't let this throw you. You approach the problem the exact same way. Okay, so determine the truth value for each simple statement. Then using these truth values, determine the truth value of the compound statement. Okay, so the first statement is $1 million is greater than or equal to 1 billion. Okay, so notice the or equal to. So you're going to have to break this up into two statements. Okay, so our first statement that we're going to work with is that $1 million is greater than $1 billion. So 1 million is greater than 1 billion. That's statement P. Then we have to do the other option, which is that $1 million is equal to $1 billion. 1 million is equal to 1 billion. That is statement Q. Now we have to write this in symbolic form. So $1 million is greater than or equal to $1 billion. So that would be P or Q. Now, you do not have to go through and construct a whole truth table if you don't want to, because you know whether these statements are true or false. $1 million is greater than $1 billion. That is a false statement. If I had $1 billion in the bank and all they gave me was $1 million, I'd be upset. $1 million is equal to $1 billion. That is a false statement. So we're looking for the or category between two false items. If you have an or with two false items, it is going to be false. So this statement would be false, and I found that out without having to do a truth table. Let's look at one more example. So we're going to determine the truth value for each simple statement. Then we're going to use their truth values to figure out if the whole compound statement is true or false. Okay? So Angelina Jolie is an actress. Okay, so Angelina Jolie is an actress. We're going to call that statement B. Zac Efron is a janitor. Okay, Zac Efron being a janitor is going to be statement Q. Johnny Depp is not a plumber. So we're going to have Johnny Depp being a plumber, statement R. Okay, now let's go through those at just face value. Okay, is Angelina Jolie an actress? Yes, she is. That is a true statement. Is Zac Efron a janitor? No, he's not. That is a false statement. Is Johnny Depp a plumber? No, Johnny Depp's not a plumber. That is a false statement. So now that we know the true values of the statements, now we can build the compound statement. So we have Angelina is an actress, or Zac Efron is a janitor. So Angelina is an actress, or Zac Efron is a janitor. Notice the comma. You should put that in a set of parentheses. But is another word for and. Johnny Depp is not a plumber, so not R. Okay, so let's first figure out the P or Q truth value. And then we'll figure out the not R truth value. And then last, we'll figure out the truth value of the conjunction. Okay? So P or Q. You have a true and you have a false. As long as one of them is true, P or Q will be true. Not R. Not R is going to be the opposite of false, which is true. So we are doing a conjunction, which is and in a conjunction, as long as they are both true, the conjunction is true. So this statement is a true statement. Angelina Jolie is an actress, or Zac Efron is a janitor, but Johnny Depp is not a plumber. True statement.
So that is for our week 13 discussion. So meron din akong pinost sa Google Classroom link paano gumawa ng truth table mula sa compound system. So please watch this. This is just a 14-minute video. Napaka linaw ng explanation din ito. Actually, so pasensya na I might not be able to put it in our video discussion here because of copyright issues. But ito, it's already here in our Google Classroom. So I'll just save this one for us to be able to post it. So you could see we have here in our topics, we have the logical connectives. So this is our video for week 13. So we have there paano gumawa ng truth table and also the video that I have included here in our presentation.
So for activities, kindly refer to your handouts or PDF files. Only answer activity one for our week 13 discussion on topic. So before ending this video, I would like to say thank you everyone and share Bible verse from the book of Mark chapter 9 verse 23 said Jesus everything is possible for one who believes. So thank you again everyone and God bless.